Good day. Today we are working on section 9.3, tests about a population mean. I'd like you to do the warm-up on your own. You can check your answers against the website later on or before you start the notes today. The warm-up will give you some practice with confidence intervals and the one proportion Z test for from section 9.2. And so we are now going to be looking at tests about population means. And the tests we will be using in this lesson is the one sample t-tests. And examples that we'll be looking at include one-sided tests, two-sided tests, and matched pairs. So similar to what we have done in chapter 8 on confidence intervals and in 9.2. All right, so in section 8.3 we looked at creating confidence intervals for the population mean. We created the confidence interval in two ways. We looked at estimate plus or minus the critical value times the standard deviation of the statistic, so standard deviation over the square root of n. And so here we could use a normal standard deviation distribution, to create the confidence interval. If the population standard deviation was known. And of course, usually we don't know the standard deviation, because if we did, we probably would know the mean as well. So what we tend to do is use the estimate plus or minus t critical value times the statistics standard deviation divided by, times the sample standard deviation divided by the square root of n. So it is unlikely that we know the population standard deviation. So we can use the t-distribution with n minus 1 degrees of freedom and the sample standard deviation. Sx. And remember that as n approaches 30, t starts to look more and more normal. All right, so we're going to be doing similar things with our tests. When we're doing hypothesis tests, we need to create a test statistic. So the test statistic is the statistic minus a parameter divided by the standard deviation of the statistic. And so if we were making a hypothesis test about the mean, where h naught is that the mean equals mu naught, our parameters are mu naught, and our statistic is the sample mean, which is x bar. And our standard deviation of the statistic will be either sigma over square root of n or Sx over the square root of n. And then the test statistic becomes either Z being x bar minus mu naught divided by sigma over square root of n if the population standard deviation is known, or more likely t, which is x bar minus mu naught over Sx over the square root of n if the population standard deviation is not known. Okay, so you might be asked to calculate the test statistic. So one sample t-statistic from a sample of 17 observations has the probability 0.5 to the left of t asterisk. So if we sketch this out, and there's our t curve, t distribution, there's t star, and we're looking at, it says 0.75 to the left, so that area is our 0.75, and we were given n is 17, and so our degrees of freedom is 16. So for this, you will use the table, and you will look for t star equals 0.69. So I'd like you to pull out your t table, table B from your from the back of your textbook. If you don't have that, you can do inverse t on your calculator. So using your TI-84, you would get 0.69, and you would have done in t and the area to the left, which would be 0.75, and the degrees of freedom, which would be 16. And you should get 0.69. You should know how to use the table as well as your calculator. For example 2, if we're working the other way around, a one sample t statistic from a sample of 19 observations has a value of t equals 1.84. Give the two critical values t star from table B that bracket t. So in your table, you're not always going to have that exact value. So we were given t equals 1.84. The degrees of freedom are one less than the number of observations, so 18. And looking at our sketch, if t is 1.84, we're looking for this area. So the p-value, in other words. The p-value here is going to be between, when you look on your table, 0.05 and 0.025. Okay? What you would have found was that t was between 1.784 and 2.101. Okay? So remember, you're looking from the table for that. All right, so let's move now into actual tests. And remember, we will be using state plan, do, and conclude. I might take a few shortcuts in our notes, but for tests and for homework, you should be practicing all of the steps. So first off, what are our conditions for using the one sample t-test? Once again, we need to look at RIN, so random. The data comes from an SRS or a randomized experiment. Independent. Each sample is independent. And if sampling without replacement, we need to check the 10% rule. Remember, that is that sample size is less than or equal to 1/10 of the population size. And finally, normal. 3 different cases. Either the underlying population is normal, and if that's true, then you can go ahead. Or the central limit theorem applies, that's CLT, and then the sampling distribution is approximately normal if n is greater than or equal to 30, or if it's not greater than or equal to 30, if n is between 15 to 30, we need to inspect the data to see if it's roughly normal, there's no outliers, or strong skew. If it's less than 15 or equal to 15, then we are going to make sure the data is close to normal. If clearly not normal, or if it's clearly not normal, or if there's no outliers. Okay, so you need to be careful in those cases.